Okay, polynomial inequalities, 3.6 again. Definition of polynomial inequality. Let f of x be a polynomial, then an inequality of the form f of x is less than 0, f of x is greater than 0, f of x is less than or equal to 0, or f of x is greater than or equal to 0 is called a polynomial inequality. All right, so if we want to write the solution set for a polynomial inequality, so for part A, we have x squared minus 6x plus 5 is greater than 0. So what we mean by find the solution set is we're looking for all values on the x-axis where f of x, meaning y, is greater than 0. That means positive. That means above the x-axis. So if you look at that, you can see that the places where it is above the x-axis are the areas from negative infinity up to 1, not including 1, and from 5 to infinity. So that is the solution set for that inequality. That is where the function is greater than 0. So for part B, it's less than or equal to 0, same function. And what we're looking for is the solution set is the set of all values on the x-axis where f of x, meaning y, is less than or equal to 0. That means negative or 0. That means below or on the x-axis. And so this is where that happens. And so between 1 and 5, including 1 and 5, is going to be the solution set. So that is what we mean by solving a inequality, a polynomial inequality. So here's another example. Solve the quadratic inequality 3x times x minus 1 is greater than 10 minus 2x. So the first thing we have to do is write the inequality in the form f of x is greater than 0. We want to get everything on one side. So we can do that. I'm just going to click through this real quick because you can pause it if you need to write this down. And so we're getting it all on one side. And now we're going to find the real zeros of the related equation f of x equals 0. So we've got 3x squared minus x minus 10 is equal to 0. And so we just need to factor that. We'll have 3x plus 5 times x minus 2, which means that the solutions are negative 5/3 and x equals 2. So what we're going to do is we're going to break up the x-axis into intervals defined by those boundary points. And so we're going to have negative infinity up to negative 5/3, then negative 5/3 to 2, and then 2 to positive infinity. And we're going to set up, we're going to look at the x-axis and just mark those two zeros. And we're going to make a chart where we look at what's happening to each factor on those intervals. So for the interval from negative infinity to negative 5/3, we can just try one of the values that's in that interval for x. So negative 2, if we try that, we get 3 times negative 2 plus 5, which is negative 1. So the function right there, that part of the function, that factor is negative. Next, we can try that same negative 2 in the second factor, which is x minus 2, and we get negative 4. So that makes that factor negative. So 3x plus 5 times x minus 2, negative times negative is positive. So the function is positive on that interval. Now we're going to look at the interval from negative 5/3 to 2. So we're going to try an x value in that range. So that could be 0, the easiest one. Plug that into 3x plus 5, and you get 5. So that means that factor is positive on that interval. Next, the factor x minus 2, if you put 0 in there, you get negative 2. So the factor is negative on that interval. So when you multiply the two factors together, positive times negative is going to give you negative. So on that interval, the function is negative. From 2 to infinity, we could try 3. Plug that into 3x plus 5 and you get 14. That's positive. For the x minus 2, that's 3 minus 2 is 1. That's also positive. And so the function is positive on that interval. And so you can see where the function is greater than 0, which is what we're looking for. It is a strict inequality, so we're looking greater than 0, and that happens on this interval and this interval. That's when the function is positive. So those two sets, negative infinity up to negative 5/3, union 2 to infinity, that's going to be your solution set because you can see that is where the function is above the x-axis. Those values of x from there down, and from there up, those are the places on the x-axis. Those are the solutions, the x values where this function is positive above the above the x-axis. And you can see that, on the graph. If you had the graph already, you'd be able to see it immediately, but we're just talking about how to figure this out if you don't have the graph. Here's another example that's a little more complicated, and it'll help you see why we're doing all this work. I mean, on the one before, you might not have needed to do all that, but as the graphs get more complicated, you kind of do because there's just a lot more going on. So solve the inequality x to the fourth minus 12x is greater than or equal to 8x squared minus x cubed. So again, the first thing we're going to do is write the inequality in the form f of x is greater than 0. So we're going to get everything on one side, and this is what it looks like. And now we are going to find the real solutions to the related equation f of x equals 0. And we can factor out the x, but we also have to solve that cubic polynomial. And so to do that, you might have to go through a few values. Remember that the possibilities are going to be all the factors of 12. And so I did that already, and I found out that -2 works. So I just put that in for synthetic division, do that synthetic division out, and you're going to get that your polynomial that's left over is x squared minus x minus 6. So the factorization is going to be x times x plus 2, because -2 is a 0, and then you've got that quadratic left over, which is factorable. So you'll have x plus 2 times x plus 2 times x minus 3. So that's the factorization of this polynomial, and it looks like this. So you can see what the solutions are for what the zeros of the polynomial are. That's going to be 0, -2, and 3. So the intervals that you're going to set up are going to be on your x-axis. You're going to be going from negative infinity up to -2, from -2 to 0, from 0 to 3, and from 3 to infinity. So you're going to set up your little table, and you're going to have these intervals that you're going to look at for each factor. All right, so these are pretty simple. We don't necessarily have to plug in anything because we can see it super fast what's going to happen. So the sign of x in each interval, all right, in the first interval, x is going to be negative infinity to -2. -2 to 0, again, x is negative in that interval. From 0 to 3, x is positive. From 3 to infinity, x is positive. Then the sign of x minus 3, you can see that from negative infinity up to -2, all those x values are going to make that negative. From -2 to 0, again, you're going to have -2 minus 3, and then everything between is still going to make it negative. For x minus 3 between 0 and 3, again, it's going to be negative because x is less than 3, so that's going to come out negative. And then 3 to infinity is the only time when that x minus 3 factor is going to be positive. X plus 2 squared is always positive because it's a square. So when you square something, it becomes positive. All right, so here are the signs for all the factors, and this will tell you what the sign of the function is over each of these intervals. So over the interval from negative infinity to -2, you've got a negative times a positive makes positive. From -2 to 0, you've got negative, positive. Again, that makes positive. From 0 to 3, you've got positive, negative. That's going to be negative. And then from 3 to infinity, they're all positive, so that's going to be positive. So the places where this function is positive are from negative infinity all the way up to 0. And since this is it's greater than or equal to 0, are the things we're looking for, we can include 0. and we can include -2. So we can say that all the way from -infinity up to 0, the function stays positive. And you can see that in the graph right here. It's above the x-axis the whole time from -infinity all the way up to 0. So that interval, -infinity up to 0, and we can include 0 because it's greater than or equal to 0. And then the other interval where it is positive is going to be 3 to infinity, and we're going to include 3 because it's allowed to equal 0. And so this would be the solution set for this polynomial inequality.